Alright, 1.4 lines. Let me write out this definition here. Let P equals x1, y1 and Q equals x2, y2 be two distinct points. That means these two are different points. They're not the same point. If x1 does not equal x2, the slope m of the non-vertical line L containing P and Q is defined by the formula m equals y2 minus y1 over x2 minus x1. x1 does not equal x2 once again. So basically it's the rise over the run. Now, if you do have a situation where x1 equals x2, then L is a vertical line, and the slope of m of L is undefined. It's undefined because it results in division by 0. If you think about it, if x1 equals x2, like let's say x1 and x2 are both 5, well, on the bottom you have 5 minus 5, which gives you a 0. You can't divide by 0. That's why you get an undefined slope. Okay? Alright, let's do an example. Find the slope m of the line containing these 2 points. Alright, so what I'm going to do here, I have my equation, y2 minus y1, or the rise, over x2 minus x1, the run. Here's my x1 and y1. Here's my x2, y2. You could actually do it the other way around if you want. You could make this one your x1, y1, and this one your x2, y2. Just make sure that you don't accidentally do x1, y2, and x2, y1. Make sure that if this is your x1, this has to be your y1. If this is your x2, this has to be your y2. And then we can just plug them in. Negative 3 minus 2 over 5 minus 1. Negative 3 minus 2 is negative 5. 5 minus 1 is 4. There's your slope. Okay. You guys can go ahead and do this one. Okay. Alright, draw a graph of a line that contains the point 3, 2 and has a slope of 3/4 and negative 4/5. I think I meant to give this one a bigger box and this one a smaller box. So what I'm going to do part A up here. I'll just draw a little arrow. That's not such a straight line. There we go. I'll just do part A up here and I'll do part B down here. Okay, so we know it contains the point 3, 2. So I'll go 1, 2, 3, 1, 2. There's my point. If it has a slope of 3, 4, this is the rise and this is the run. So I'm going to go up 3, 1, 2, 3, and over 1, 2, 3, 4. There you go. There's my line. Okay. Alright, let's do part B. And I'll use green this time. Okay, so once again, 3, 2. But this time, I'm going to go down. Anytime you have a negative slope, you're going to go down instead of up. But you always move to the right. Okay? So, 1, 2, 3, 4. 1, 2, 3, 4, 5. Aye. Third time's a charm, right? There we go. Okay. So there's my line. Okay, you can try this one. Alright, example 3. Graph the equation x equals 3. Okay, anytime you just have an x, there's no y in the equation. This is what you're going to want to do. You're going to want to find where that point is on the x-axis. You're going to draw a vertical line. Okay, and just a reminder, this has an undefined slope. Okay, so there you go. Alright, equation of a vertical line. Alright, I wrote down what we just discussed in the previous example. A vertical line is given by the equation of the form x equals a, where a is the x-intercept, which is exactly what we have here. We have x equals 3. 3 is the x-intercept, and we have a vertical line. All right, point-slope form of an equation, point-slope form of an equation of a line. The equation of a non-vertical line of slope m that contains the point x1, y1 is y minus y1 equals mx minus x1. Okay, so for example, an equation of the line with slope 4, let's see here, let's use green, slope 4 and containing the point 1, 2 can be found using the point-slope form with m equals 4, x1 equals 1, and y equals 2. What is the equation? Alright, so we've got y minus y1 equals m x minus x1. And they gave us what all these equal. It would have been enough for them just to give us this information, but they were nice enough to give us the rest. So I have y minus y1, which in this case is 2, m times x minus x1, which in this case is 1. Voila. Whoops. There we go. Alright. Find an equation of the horizontal line containing the point 3, 2. Okay, let's graph this first. The point 3, 2 is here, and we've got a horizontal line going. Okay, now when you have a vertical line, you're just looking for the x-intercept. When you have a horizontal line, you're going to look for the y-intercept, which in this case is 2. Okay, anytime you just have a y, you're going to get a horizontal line. And the slope is going to be 0. Okay? Alright, so equation of a horizontal line. Alright, I wrote down basically what we just discussed. A horizontal line is given by an equation of the form y equals b, which is exactly what we had up here, where b is the y-intercept. So up here we had y equals 2, because 2 is the y-intercept of the equation. Alright, find an equation of the line containing the points 2, 3, and negative 4, 5. Graph the line. Alright, I'm actually going to graph the line first, just because I think it's a little bit easier to do it that way. So we've got the point 2, 3, and negative 4, 5. Close. Alright, so we're looking for the equation. Let's put the equation, since we just learned slope point slope form, we'll use that equation. Okay. First thing we need to do is we need to find the slope. Let's use purple. So my m is y2 minus y1 over x2 minus x1. I'm going to make this my x1, y1, and this my x2, y2. So I've got m equals 5 minus 3 over negative 4 minus 2. 5 minus 3 is 2. Negative 4 minus 2 is negative 6. This reduces to negative 1/3. So there's my m. Okay, so now when I write my equation, let's go to red. I've got y minus y1 equals m x minus x1. You have your x1, y1, 3 and 2, and you have your m, so just plug everything in. So y minus 3 equals negative 1/3 x minus 2. And we're golden. You guys can do this one. Alright, slope-intercept form of an equation. An equation of a line with slope m and y-intercept b is y equals mx plus b. This is the equation that I tend to use if I have a choice. But I want you guys to be familiar with point-slope form, slope-intercept form, and we're going to also get to general form, just because depending on the problem that you're given, usually or oftentimes there's one equation that's easier to use than the others. Personally, I tend to like this one, so you'll see me use this one a lot, but you don't have to, unless if the problem specifies which form to use, and that's the form you have to use. But if it doesn't specify, I don't really care. Alright, you guys can go ahead and try these two. Example 7, find the slope m and the y-intercept b of this equation. Graph the equation. Alright, so we're given 2x plus 4y equals 8. The way I'm going to do this is I'm going to put this in slope-intercept form. So I'll subtract 2x, subtract 2x. This goes away. I've got 4y equals 8 minus 2x. I'm going to switch these two. So now I have 4y equals negative 2x plus 8. Make sure the negative stays with the 2x. Now I'm going to divide by 4. This cancels out. Negative 2 over 4 reduces to negative 1/2. 8 divided by 4 is 2. There we go. So that's my m, that's my b. M equals negative 1/2, b equals 2. So when I graph this, I'm going to start with my y-intercept. My y-intercept is 2, and my slope is negative 1/2, so I'm going to go down 1 over 2. There are my 2 points. Imagine that's a straight line. My bad. Alright, so now we have the slope and the y-intercept. And we have the graph. We're done. Alright, general form of a linear equation. Alright, the equation of a line is in general form when it is written as ax plus by equals c. This is usually how problems assign you an equation. Usually it's something times x plus or minus something times y equals some number, and then you have to work with it. And this is where a, b, and c are real numbers, and a and b are not both 0. So a or b could be 0, but both of them can't be 0. Alright, graph the linear equation 2x plus 4y equals 8 by finding its intercept. So let's find its x-intercept first. So I've got 2x plus 4 times 0. I'm going to plug in 0 for y. So now I'm left with 2x equals 8. Divide both sides by 2. X equals 4. So the first intercept, the x-intercept, is 4, 0. Now let's find the y-intercept. So I've got 2 times 0 plus 4y equals 8. 4y equals 8 divided by 4. Y equals 2. So the y-intercept is 0, 2. And 2 points is all you need to graph it. So I've got 1, 2, 3, 4, 0, 2. Ay. Close enough. Okay? Alright, you guys can try this one. Criterion for parallel lines. 2 non-vertical lines are parallel if and only if their slopes are equal and they have different y-intercepts. Alright, I know it's been a little while since you guys took geometry, so just a reminder, this symbol means parallel. And this, the IFF, that's not a misspelling. This means if and only if. It's just my abbreviation, okay? Alright, so, for example, show that the given lines of the following equations, there should be an S here, are parallel. So, what I'm going to do is I need to find the slopes and the y-intercepts. If the slopes are the same and the y-intercepts are different, then these two equations are parallel. So let's take a look at the first equation. I've got 2x plus 3y equals 6. I'm going to put it in slope-intercept form. So I'm going to subtract 2x, 3y equals negative